All right, so this is lesson 2, simplifying rational expressions. And remember, you know it's a rational expression when you see a division symbol. And just a little calculator tip: to get this division symbol in your calculator, you hit alpha, y equals, and then it's the first one, number 1. Okay? So, all right, when we're simplifying and solving, simplifying is we're just kind of just putting everything together. You won't see an equal sign. You won't see that there. And then when you're solving, you will see an equal sign. Oh, sorry guys, hold on. You will see an equal sign, and you're looking to see what the variable is equal to. Okay? All right, so it says here, rational expression is in the form a over b, where a and b are some type of polynomials. Okay, so rational expression, you'll see the division symbol. And when we're simplifying rational expressions, we want to be able to cancel out the same factors from the numerator and the denominator. Okay, so for example, to simplify this expression right here, you notice there's no equal sign, so we're not looking to solve for x, we just need to simplify this. Okay, so to simplify it, we're just gonna cross out, we're gonna just reduce this. So we try to look for what goes into 21 and 18 evenly. I know 3 goes into 21 and 18, so 3 goes into 21 7 times, and 3 goes into 18 3 times. And then I look at 7 and 3, there's nothing that goes into 7 and 3, so I can just reduce it that way. And then over here, I have x in the numerator and x cubed in the denominator, which means I can cancel out an x in the numerator and x in the denominator, and then in the denominator, I have x to the square power. So to rewrite this is 7 in the numerator, 3x squared. And this is my simplified version. Okay, so just look for the common factor between the numerator and denominator in the numbers. All right, so if you are looking to reduce this and you're trying to look for, well, what goes into 80 and 64, you can start with, well, looks like they're both the even numbers, so you can start with 2 and then keep reducing it. Or you can use your calculator. Okay, if you go to math, and if you go to over to numbers, and it's this one right here, greatest common divisor right here, if you use this little thing they have here and you put in those two numbers, if you're looking for what's common between 80 and comma and 64, it'll tell you. If you hit enter, it tells you that 16 goes into both of them, which means that 80 divided by 16 is 5, so I can reduce this down to 5. And then 64 divided by 16 is 4. So 16 goes into 64 4 times. So that's another way you can reduce it, 5 over 4. And then you have x over 4 in the numerator and x over 4 in the denominator, so they just cancel each other out. So you have 5 over 4. Okay, this is the simplified version. Okay, all right, let's look at 32 and 80. Let me try this again. I like this. Kind of just gives you a heads up. What is it? So we do 32 here, 80 here. Let's see what goes into 32 and 80. 16 again, which means that 32 divided by 16 is 2. And then 80 divided by 16, we just did it here, which was 5. And let's look at the variables. You have n cubed and n in the denominator. So if I take out an n in the denominator and take out n in the numerator, you have n squared left. So you have 2n squared over 5. Okay? And then here's some more examples for you to try. Alright, next page. We have some other type of rational expressions to simplify, and again, remember that it's a rational expression as long as you see a division symbol. Okay, all right, for something like this, whenever we throw in like addition and subtraction signs into your problems, they get a little bit more difficult to simplify. And remember that in the lesson I told you that we want to be able to cancel out same factors. Okay, factors. Factors is something that's being multiplied together. That makes it a factor. But this is not being multiplied, so I can't just cancel things out until I factor everything out. So for example, in the numerator, I have 40 times n. There's really nothing to factor, but I know that 40 and are being multiplied together. But in the denominator, I have to factor out the common term between these two. So what is common between 70 and 60? Okay, you can use your calculator. I mean, I can see that it's 10. 10 goes into 70 and 60. But if you can't see that, you can just go to your calculator and try to figure out what is the common factor. So 70 and 60 is 10, because 10 goes into both of them. So to be able to factor it out, I'm going to put that common factor outside, put parentheses, remember it's in factored form whenever you see some parentheses, and just divide it out. So 70 divided by 10 is 7, and you have the n squared, and 60 divided by 10 is 6. So that is my common factor. And now that it's factored out, now I can reduce this. So I can go 10 goes into 40 4 times, and 10 goes into 10 once. Now the ends, I cannot cancel them out because it's, we have the subtract 6 attached to it. So to rewrite this, you have 4n over 7n squared minus 6, and that is my simplified version. I cannot simplify this anymore. Okay. So same thing here. At the moment, I cannot cancel out the p's because I have this numbers attached to it. So I'm going to try to factor it out. I'm going to factor out the numerator, see what's common between 3 and 15. I know 3 goes into both of them. So you can, again, if you can't really see that, go to math, numbers, and just try to find the common factor between those two, between 3 and 15, to be able to factor it out. Alright, like I said, 3 goes into it. So 3 goes, so I'm going to put that common factor outside. We did this in unit 2. And then divide it out. So 3p divided by 3 is just p. 15 divided by 3 is 5. And then in denominator, I also have p minus 5. I'm just going to put parentheses to show you that I can now cancel these two factors out. So all of this will end up equaling to 3. Alright, you can just keep going with these examples, but I did want to show you how you can, if it's a multiple choice, remember you can always just kind of check it using an irrational number, but let's factor this out. So I cannot just cancel stuff out because I have a subtraction sign here, so I'm going to try to factor out the numerator. Let me see what goes into what I can factor, the greatest common factor between these two. So I have 45, what is that, 63, alright, 9 goes into both of them, so I'm going to write that common factor out here, put in parentheses because I'm factoring, and so 45 divided by 9, that is 5. So I'm going to write that 5 here. And also, if you notice, there's a common variable p here, so I can actually factor out a p as well. So I'm going to factor out 9p, and then so I have 45p squared divided by 9p, so 45 divided by 9 is 5, p squared divided by p, that you just have 1p left in here, minus 63 divided by 9 is 7p. Okay, and then in the denominator I have 27p cubed. Alright, so what is it that I can simplify? Well, I look at 9 and 27. Let me see if I can reduce this. 9 goes into 9 once, 9 goes into 27, so 27 divided by 9 is 3. And then I have a p in the numerator, I can cancel out p in the denominator, so I have p squared. So let me just rewrite all of this. So you have 5p minus 7 in the numerator, all of this got canceled out, divided by 3p squared. Let me see if I can find my answer. Answer C. Okay, and if you want to be able to check this in your calculator, see if you got this right, just try an irrational number. Just plug in like a square root and or pi into your variable here, plug it in here, and see if the decimals match up. Okay. All right, a few more examples here. For number 10, I have a subtraction sign here, so which means that I have to first factor the denominator before I can simplify it. Okay, so I'm going to just put equal sign here. I'm going to factor out the denominator. I'm going to try to think of what goes into 21 and 35. If you put it in your calculator, you'll see that 7 goes into both of them. And oh, this should have been an x, typo. And then there's an x common variable x between both of them. So 21 divided by 7 is 3, and then you have your x squared, and if you take out an x, you just have x by itself. And 35 divided by 7 is 5, and then you have x. In the numerator, I have 14x squared. Now that I have it in factored form, I can try to simplify this. So 14 and 7, 7 goes into 14 2 times, 7 goes into 7 once. And then I can cancel out x in the denominator, x in the numerator, and just have x by itself. So you have 2x over 3x minus 5. And I cannot cancel out the x's because it has minus 5 here. 2x, and then all of that, which is a. Okay. Alright, this one, this is a trinomial, so we have to first try to factor out this trinomial, and then we can simplify. So in the numerator, I have r plus 7, and then in the denominator, factoring trinomials, you know, it's in factored form when you see some parentheses. So I have r and r. What two numbers multiply together give you 21, but when you add together, give you 10. Another, which is 7 and 3, okay? But if you can't really see those numbers, just remember that whenever we're trying to factor something, you can look at the factors if you graph it and look at your x-intercept. So if I put the denominator in my calculator, then I'm going to graph it, you can notice that my x-intercept is at 1, 2, 3, 4, 5, 6, 7, and 3. But when we write it as a factor, we have to write the opposite. So if it's negative 7, you write positive 7, negative 3, you write positive 3. That's how you can write it as a factor. Alright, so in the numerator, I have r plus 7 here, r plus 7, so I can just cross those out. And once you take everything out in the numerator, which means that there's a 1 there, and because you can't just leave it blank. And then you have r plus 3 in the denominator. The answer choice is B. Okay, let me, same thing here, you have a trinomial, so let me factor it out. I'm just going to use my calculator's help here. I'm just going to put x squared plus 13x plus 42, and then now we're going to graph it. It's kind of hard to see here, but it looks like my x-intercepts are negative 1, 2, 3, 4, 5, 6, 7. Negative 7, so I write positive 7, and negative 6, I write positive 6. Okay, and then you have x, and then x, and then in the denominator, and I can factor this out, I can look at, see that 2 goes into 2 and 14, so I'm going to factor out a 2, so you have x plus 7 in the denominator, and all that so that I can cross these out. So in the numerator, I have x plus 6 over 2. That's your choices there. Okay? So, hang on. I'm going to stop this video here, and then I'm going to start a new video to be able to multiply rational expressions. How do we multiply expressions that have fraction bars in them? How do we divide polynomials? Okay, dividing rational expressions. I'm going to show you how do we add rational expressions, and how we subtract rational expressions as well. Okay, I'll do that in the next video. And then we have all this, and then we have the solving stuff coming up. Okay.